Welcome to Nano Analytic. Today we would like to present to you the AFM and SEM scientific instrument. The AFM and SEM is an established member of the nanometronome AFM family developed by Nano Analytik. The mechanical characterization of a microelectromechanical system and a micromanipulation of small parts are realized with an atomic force microscope integrated within a scanning electron microscope. The piezoresistive thermomechanically actuated cantilever, or an active cantilever, allows for the integration of an AFM inside an SEM. The compact, modular, and optical-free AFM setup enables for both probe scanning, sample scanning for fast imaging, and novel nanofabrication. The AFM operates within a closed-loop system, the probe positioner which allows addressing the cantilever tip anywhere within a range of 18 by 18 by 10 millimeters at a precision of 1 nanometer. The AFM and SEM scanner provides qualified metrological capabilities and yields the following performance criteria: a 0.4 nanometer resolution in both X and Y axes, and a 0.2 nanometer in the Z direction, linear deviation less than 0.1%, and repeatability less than 0.1 nanometers. The combination of AFM and SEM imaging, energy dispersive X-ray spectrometry, focused ion beam milling, field emission scanning probe lithography, tip-based electron beam induced deposition, and nanomachining provides a new and unique tool for correlative nanofabrication and microscopy. Thus, the AFM with active cantilever integrated into the SEM, AFM and SEM, can generate and measure nanostructures in situ without breaking vacuum or introducing contaminants. The AFM is mounted on an SEM specimen stage. The AFM and SEM allows tilt angles from 60 degrees to -10 degrees. It allows a navigation of the tip with the SEM and simultaneously perform SEM AFM correlative microscopy mode at an optimal working distance of 4 millimeters. Our active cantilevers are equipped with diamond tips, allowing for precise and versatile movement of the AFM cantilever on a MEMS bridge. By applying a mechanical load onto the micromechanical MEMS bridge with the cantilever, we can bend the bridge. The cantilever deflection is measured with the integrated piezoresistive sensor. Accounting for the stiffness of the cantilever, the bending of the cantilever, and the bridge bending, we can determine the stiffness of the bridge. The video exhibits an active cantilever tip interacting with a MEMS bridge. This technique is known as nanomilling, mechanical machining of materials at the nanoscale. Combining AFM and SEM-based meteorology and accounting for the diamond AFM tip, we can machine the MEMS bridge. In this manner, we can establish the material's parameters, like the Young's modulus, by using the Hertz model. The AFM tip operates as a nano indenter. After nanomilling, switching the AFM nanomilling mode to the non-contact imaging mode, we can measure the profile of the trench formed with sub-nanometer resolution. The next video presents an example of how we can micron and nanomanipulate with the AFM and SEM instrument. We employ mechanical and electrostatic forces to reel in platinum strips onto a gold ball. This combination opens a new opportunity for assembling, handling, and manipulation of microelectromechanical systems and new novel devices. What we see is the AFM inside the SEM system. The sample being imaged is a freestanding platinum bridge on a silicon substrate. The active cantilever tip, as seen in the top half, was used to obtain a gold ball. The gold ball is charged due to the imaging electron beam causing an electrostatic attraction between the platinum strips and the gold ball. This is seen as a movement or fluctuation in the platinum strips. On the left-hand side of the trench, using the cantilever as a tool to physically reel in the freestanding bridge onto the gold ball. This is achieved by manipulating the AFM cantilever. Whereas on the right-hand side, we are seeing the same reeling effect, but induced through an electrostatic interaction between the gold ball and the grounded platinum bridge. As you have seen, the AFM and SEM instrument developed by nanoanalytik provides a unique capability of analysis, correlative microscopy, fabrication, and manipulation at the micron and nanoscale. The instrument can be integrated into any SEM system, is highly customizable, and can be configured for unique applications. The active cantilever produced by the microelectromechanical systems technology enables direct, qualitatively force and three-dimensional measurements. For more information about the AFM and SEM capabilities, feel free to read our open access journal article in the link seen. On behalf of nanoanalytik, we would like to thank you for watching, and we hope you've discovered the capabilities of our systems. For more information, please visit our website at www.nanoanalytik.net.